Hi, in this tutorial, we will study the main concepts of the ER model. We will use the ER diagram as the first step in our database design. In Chapter 2, some of the exercises at the end of the chapter, for example, exercise 2.5, they provide us with some requirements about a specific database that they want us to design, and we need to follow some type of model or some type of strategy, the way that we're going to do our design, like what would be our first step. In our case, we will draw a ER diagram. For that, we need to understand concepts like an entity set, attributes, relationships, connectivities, and so on. For example, in exercise 2.5, they're giving me some requirements for this case, no town records, that they want us to design a database for them. And they're giving us, providing some information. For example, there they talk about each musician, the records in no town has a social security, a name, and an address. So what we will study in this chapter is, okay, from that information, what is going to be an entity? What is an attribute? What is a relationship? Okay, um, and so on. There are a lot of requirements here, and we need to be very careful in the way that we identify them. Okay, so we will review my notes for this, for the ER model. So the ER comes from the entity relationship, so we want to connect those rectangles with those other symbols that I have there that looks like a diamond or a rhombus, and then those ellipses are going to be my attributes. As you remember from the previous chapter, we were discussing several database systems, and then we say that we will be working in this course in the relational model that has been very successful since the 70s. And then we still have the latest generation is object-oriented databases, which is covered in another course, which is database concept, which is CSCI 480. Okay, so one paper written by Peter Chen in 1976 is the one that he proposed this system. And then for that, one of the main concepts is entity or an entity set, which is basically an object of a concept that has some properties and we can distinguish in the system. For example, in the exercise 2.5, musicians will be an entity. It's an object that will have some attributes, some properties, like for example, has a name, a social security, maybe has a salary, and so on. Other examples include, for example, person, company, car, department, students, and so on. Now, entities can be classified as either strong or weak. And I think the example that I have here in my notes is a very good example to make the distinction between strong and weak entities. Strong entities exist by itself, while weak entities that exist and depends on the existence of another entity. In the example here, let's suppose that in a company we keep record of employees, of course, but then dependents, we have dependents because we providing them maybe with some benefits, and they depend on an employee, that maybe the children or the spouses of the employees. So if the employee is no longer working in the company, we don't need to keep the information for those dependents. So this is a good example. I mean, the employee is no longer working, then we take the dependents away. Okay, now attributes. Since entities are objects, uh, objects can be distinguished by the attributes. For example, here in employees, this is the rectangle, and then these ellipses illustrate some of the attributes like date of birth, employee identification, which is underlined, in this case is the key, the primary key, name, and salary. And then dependence is a double line rectangle. That means it's a weak entity, while employees, like we said in the example, is a strong entity. And then we see that dependence, the name has a dotted line. That means that it's a partial key. Now, we shouldn't confuse from the previous chapter when that we were talking about keys and candidate keys, that every table has to have a key. We're not talking about tables yet. we're using this to work in the design of our database. So uh, don't confuse. I mean, we identify what will be the keys or partial keys, but we're not employees right now is not a table. We as the next step after the ER, we're gonna see how we're gonna map an ER into a set of tables. Now, attributes can be simple or composite. Simple is one the most common. I mean, it's like for example, here in employees again, phone number is simple is just the ellipse there, and then that means we cannot extract any further information. If I want, for example, to distinguish the area code from the rest of the number, then I should have that as a composite. Like in this case, name is a composite attribute because if you see name for employee has a last name, a middle name, and a first name. Then if I want to distinguish all those three components of the name. If I take away those extra ellipses that come from the ellipse name, then name becomes a simple uh, attribute. The same address is a simple. I mean, no, I'm sorry, it's composite. Date of birth is simple. And again, date of birth could be composite if that's what I need for the application. If I want to distinguish the year, the day, and the month of the birth. Now here, age is a derived attribute, which means with date of birth, I could get information from age. And look at that, this is a dotted ellipse in here. Now there is multi-value attributes. Again, do not confuse these, or this contradicts the rule, the first rule in the relational system that we discussed in the previous lecture. That was about we don't allow multi-value attributes. That's for tables. This is not a table. So in this case, this entity set books, it has a unique ISBN, which we underline that says works as a key, and then title, which is a single attribute. And then this double line means that authors is a multi-value attribute. That means there are multiple authors for a given book. Okay, so we talk about derive. Now, relationships. This is the other main concept because the ER comes from the E entities and R relationships. Each entity is connected with another entity with a relationship. In this example, we got students and courses. And then these are two entities, and we got here three relationships. So between students and courses, they have three relationships. One is a student takes a course. So what it means is an object from here takes an object from there, and that calls takes. That relationship is called takes. Notice that relationship could also have attributes, like for example, students drop from the course. It says we record the year and the semester when that relationship happened in between those two objects, and they say we completed. And then when they completed, look at that, we got the semester, the year, and the grade that they have it. Now, the degree is the number of entities that participate in the relationship. For example, these are relationships that are binary. Why? All three. Drop has two entities, students and courses. Takes is also binary, and completed is also binary. So the first one, degree one, that means we only have one entity. Here, another example, students. So here, on this side, we got a student that is a classmate of another student. So it's a relationship that participates with itself. This is a very interesting type of relationship, a relationship with itself, which is students. So binary, we got all those examples before, students. So there are two relationships. I'm sorry, two entity sets that participate of the relationship. When we got three or more, and usually we don't go with more than three in most of the applications, but three or more, we'll call that ternary relationship, like in these examples. Now the connectivity, which will be the mapping. For example, here in the students, the connectivity can be one-to-one, one-to-many, or many-to-many. Like we say, one student takes many courses, and they all have some implications. So there are three types of connectivities: one-to-one, one-to-many, many-to-many. And here are some examples. Here, Mary. So this is a unary relationship, and then here is a one-to-one. So one person is married with another person. So again, if we change to one to many, one person is married to many persons, so that changes the semantic of the meaning. So parent is a one to many. One person is the parent of many. Prerequisites, courses. Several courses may be the prerequisites of several courses or many courses. Binary is the same. Professors, one professor is the chair of one department. And then the one-to-one also implies that cannot be more than one department. If that person wants to chair two departments, these wouldn't allow. I mean, that's also an implicit constraint. Here, one to many. So one to many, again, a person may own many cars, professors, many to many teachers courses. Now, if we have that a professor teaches just one course, that would also imply that that course only belongs to that professor and nobody else can teach it. And here it says, okay, all the professors are able to teach that course too. So this has on many. Okay, so in the next lecture we will work more with the ER model. Thank you.